Welcome back, students. In this video we're going to cover Module 2-2, angle relationships. The standard for this one is GR 1.1. I can find the measure of angles using the angle relationships and properties of perpendicular lines. Alright, so on the left we're going to start out with some vocabulary. So it says complementary angles. Just highlight this because it's very important. And matter of fact, I'm just going to go ahead and highlight the other word because it's very important too. Okay, so complementary angles. These are two angles with the sum of, pen won't open, 90 degrees. So examples we have, you can just have two different angles that add up to 90. 40 plus 50 would be 90. Or you've seen before, 90 degree angle. It's always a problem with this camera. Sorry. The box represents this is a 90 degree angle. So you may also have that it's either bisected or just has another line coming off of it. And in that case, one side might be 55 and the other side might be 35. If they're going to equal 90. That's the point. And so supplementary angles. These are two angles with the sum that total 180 degrees. And so an example below, so a straight line is 180 degrees. If you were to have a line coming off of this to make two different angles, excuse me, okay, one might be 130 and the other one might be 50, but they're going to equal 180. All right, let's look to the right here. We have interpreting diagrams. I'm going to zoom in a little bit, try to kind of color code some things. Apparently this is as far as I can go. Make sure I'm still recording. Sorry, it's a little shaky. Alright, so interpreting diagrams can be assumed. So all points and lines are coplanar, which these are all on the same page. And this is a plane. G, H, and J are collinear. That's because they're on the same line. HM, HL, HK, and GH intersect at point H. So you see it all goes through H. That's true. H is between G and J. That's true. Notice it didn't say in the middle, it just said it's between. And L is in the interior of angle MHK. So MHK. And you see L is in the interior of this. We don't count M, H, or K because those make up the angle. They're on the line segments that make up the angle, so they're not on the interior, they're on the angle themselves. L would be in the interior. It doesn't say this, but if you're talking about this angle, then G and J would be exterior to this angle. Let's see. Now, here's where we go into some colors. So, GHM. So, GHM and MHL. So, MHL are adjacent angles. Remember, we discussed previous lessons that adjacent means next to, and so these are next to each other. They share a side, so they're adjacent, next to, they're touching each other, elbow to elbow, so to speak. Okay, and let's see, next one. Alright, so GHL. So I'm just going to go on the outside of this. GHL. I'll do this. And LHJ. So LHJ are a linear pair. So you notice that GH and J make up a line. LH comes off of that line, kind of like what I drew over here. So this side and this side, purple, not blue, would be 180, because we'll just do this. So this other side is 180 degrees, so this side would also be 180. So hopefully that helps make sense. And then JHK, so JHK, let's see, what do we have? Green, okay. So GHK and KHG, so see it's going all the way across. It's covering the whole line there, and those are supplementary, and that's because you see that ends up taking up the whole line, because this angle, and then we go from here to here to here. Sorry, the colors end up making it more difficult, but this is an angle and this is an angle, and they're supplementary because they 180. So just 180 here, just to remind us. Okay, things you cannot be assumed. Lines that appear to be perpendicular may not be perpendicular. All right, so there's just showing over here. I'll just do this. So they tell us that AEB and BEC are congruent, and they tell us, actually they tell us down here all four are right angles, but I'm going to prove to you that before they tell us here. So because we have the red box that tells us this is a 90-degree angle, and remember we've talked about vertical angles, if they're across from each other, so side by side or up and down, either way across from each other, those are congruent. So if this guy's 90 and this guy's 90, then the other two have to be, because in order to make 180, the only way to make 180 if one part of it's 90, the other has to be 90. It's mathematically impossible. So, but we cannot assume that lines are perpendicular unless they tell us. So they have to have the box. So otherwise, you can't just say, oh, that looks like a 90-degree angle. Angles that appear congruent may not be congruent. So unless it has the actual congruent mark, the little tick mark for the on the line, and then you'll see the little arc in the angle, and then segment, same thing. Unless we have proof or we're told in the problem, we can't just assume something. That's the purpose of all this. I hope you got that. All right, so let's back up. We're going to come over here, and I'm going to approach this problem and teach it to you guys the way I do it. So as I'm reading, so find the measures of two complementary angles. So I'm just going to go ahead and highlight this. Now, before I go any further, highlight it a little better and really mess up the camera, I'm sure. So complementary means that these two angles equal what? Not 180, but 90. Okay, so I'm just going to start with 90 equals. So now I can look at the rest of the problem when the focus comes back, and I can write this out. All right, so two complementary angles. If the measure of the larger angle is 5 more than 4 times the measure of the smaller angle. Okay, as I've said in class before, whenever we have these little comparisons in the word problems, and I know you guys hate them, and I'm sorry, I'm trying to make them easier. But whenever we have these, the smaller angle or the smaller segment or whatever, 99 times out of 100, it's going to be X. I say 99 times because over here it's not, and I'll show you. But so for here, so the smaller angle is X. So smaller angle plus, now the bigger angle is 5 more. My goodness. Okay. It's 5 more. Alright, so 5 more, we would write that as plus 5. So it's 5 more than 4 times. So 4 times, of course, it has to be 4 times the measure of the smaller angle. So it would be 4x. Alright, so again, 5 more, so plus 5, and then 4 times, so it was 4. The smaller is x, the bigger is the 4x plus 5. So these are our two angles. This is the total because we know they're complementary, and now we're going to solve for x. So we have an x and we have a 4x. So 1x plus 4x equals 5x. My plus 5 is coming down, the 90 comes down. Alright, now we're going to subtract 5 from both sides. These 5's cancel out. 90 minus 5 is 85. 5x, and that should be x equals 17. Alright, so they said find the measures, so always pay attention to what it asked. It didn't just ask for x in this case, it wants the smaller angle and the bigger angle. Alright, so whenever the smaller angle is x like this, we know the total was 90, so we could just say 90 minus x, or 90 minus 17 is 73. Now it only works when one of them is x. Now, but we're going to also just plug it in just so we have it. All right, so 4x, so 4 times 17 plus 5. All right, so 4 times 17 is 68 plus 5, so 78. Oh, I'm sorry, 68 plus 5 is 73. So wanted you to see you get there both ways, but you know, if you can make it a little easier and just do it in one step, you know, might as well. All right, so the check, that's for you guys. Now this one's a little different, worded a little different, so I'm going to at least help you set it up. You can solve for x and you can figure out the second angle on your own. But so this one says we're going to check the difference between the measures of two supplementary angles is 18. Find the measure of each angle. Okay, so supplementary I know means 180 equals 180. So let's say 180 equals. All right, so the difference between the measure of two supplementary angles is 18. So you can write this a couple of ways. You'll end up with the same answer, but for this, so you can say that in this case the bigger angle, because we're looking for the difference here. Remember, the difference is we have to subtract. So in this case we would say x being the larger angle plus x minus 18. So this is the smaller angle. It's 18 less than that. Or you could just say 2x equals, or 2x minus 18 equals 180. But either way, you get the same place. So you have two x's and a negative 18. So please solve for x, and then you can either, well, you have the two different ways. You can either subtract that number from 180 to get the second angle, or you can plug it in. Now I'm going to scooch down to example number 2. Zoom in a little. These are difficult to see, at least from my old eyes. Okay, so the tangram is a puzzle consisting of 8 shapes called tans, which are put together to form images. Find the values of x and y such that AD, so let's find AD. So we got A, we got D. So AD and EC. EC. And the tangram are perpendicular. So we we know if they're perpendicular, these equal 90. So notice it says we're going to solve for x and y. We can't solve for those together, so these are going to be two separate equations. Notice this one side has our y equation, and these two over here are x's, and that's because, so this side is a 90-degree angle and this side, so we're going to put two of them. So let's do the y over here. 90 equals 3y plus 15, and over here we'll do the x's, and those equal 90, and it's, let's see, 7x plus 10 plus, goodness, alright, plus 8x plus 5. Sorry you guys, this thing's terrible. I can't get the other app working. Okay, terrible 5, sorry. Alright, so we're set up over here. Since I'm already over here and we're having some difficulties, let's, so we've got a 7x, got an 8x. 7x plus 8x should be 15x. Notice, well, actually I told you guys in class I would double it up on the video. So we got plus 10 and then plus 5. We'll go down one more. 15x equals 10 plus 5 is 15. So before I'd combined them, for now we'll do that. Of course the 90 just keeps on going because we haven't touched it. Alright, so 15x plus 15, so we're going to subtract the 15 from both sides. Alright, so this cancels. Oops, didn't mean to go all the way up there. 15x comes down. 90 minus 15 is 75. Multiply both sides by 15. And x, where's my calculator? I should know this stuff off the top of my head, and I apologize. Alright, it's 5. Sorry. 75 divided by 15 is 5. Alright, so let's do our y over here. So it's just straight up 90 equals 3y plus 15, so let's subtract the 15 from both sides. 75 minus 15 is, I'm sorry, 90 minus 15 is 75. 3y comes down, divide both sides by 3. And y is going to equal 25. Right, so that gives us both of our variables there. Alright, let's flip over, back page. Alright, so we got a check here. You guys are going to handle this. I'm just going to, so you want to find your x and y. Of course, it's going to be two separate equations, just like before. Perpendicular, that's PR, PR and QS. So P to R is right here, Q to S is right here. So you know what perpendicular means. You guys take care of the rest. Coming down a little bit. So example 3 on the left I'm going to do, and the check on the right you guys are going to do. Now, before I go here, because this is all assumed, you see there's no, we have no marks. But over here you guys are going to have congruent mark here and here. We're going to make those green. We got a congruent mark for this angle and this angle. Those are light blue. And then the box. Now, the box goes here, not here. Notice this, it goes here. Okay, just going to point that out. Stripped a few folks up. So, now I'm back to the example 3 on the left. So, determine whether each statement can be assumed from the figure and explain. Alright, so first up, CE and CF are opposite rays. So, CE, CF, they're opposite rays. So, as soon as we get a little focus here, thank you. Oh goodness, this thing's terrible. Just get my hand out of the way. Okay, yes, those are opposite rays. So let's let's just circle this, or you can, we did check marks in class, but circle works. Okay, BGC, so BGC, I'm going to try to keep these marks a little here. Alright, so this guy, and KGC. So notice though we share a side because it's the letters, the second and the third letter tell me where the vertex is, the second letter here, and then the second to the third is a side, the first and the second would be a side. And I can tell both were, and so those are a linear pair. If you do the ruler check, which I don't have one, but notice this straight line here. So yes, that is true. Alright, let's find a different color that, man, these are all pretty close, so we'll go green. Alright, so ABJ. So ABJ. And CBG are vertical angles. So, wait, yeah. CBG are vertical angles. Well, notice, whenever we got focus, so we have two lines that make an X. These are opposite sides of each other, so they are vertical angles. So let's just do this, and that is also good. Okay. All right. So statement D, BCG and DCF are congruent. All right. Before we even look at these angles, so for something to be congruent, we have one of two things. Either it has to have a mark, and there's no marks up here, or they have to be vertical angles. Now, these are vertical angles. So let's see. BCG, so this way, and DCF. Okay, well, you see, these would be on this line. This is this way, and this is this way. But these DCF, see, this is this way. BCG, those are not crossing lines. Well, yeah, because it's this way is good, but we go here, and this one goes up, so they're not vertical angles, they're not congruent. We have no way of knowing. We just know that this plus this plus this, because it's a straight line, those would be supplementary, all three of them. But we can't determine this, so this is a no. Alright, so BE and IF are perpendicular. So, we know perpendicular is identified by the box. And, BE and IF, it looks like a 90-degree angle, but remember back to the very beginning, we can't make any assumptions. There's no box, so there's no perpendicular. Sorry about that. Alright. ECB and GCB are complementary angles. So notice they have BC. So BC is going to be their common side. So we have E and we have, what does it say? H? That's kind of weird. Okay, so wait a minute. EBC, no, sorry, GBC. Okay, so again, this looks like, well, it looks like garbage is what it looks like. Hold on. So sorry. Oh, sorry. I've got to watch the screen and not my own hand and paper. So, so we don't know that that is perpendicular, so we don't know that they're complementary. So now, let's go to G. Now, G says that ICH and HCD are adjacent angles. Now, adjacent is about location, not measure. So you can look at something and see where it's at. So let me see. Let's do red. So ICH. So from here to here to here. Okay, so ICH and HCD are adjacent. So, well, if I kind of color these both in red, whenever the focus comes back, you'll see that the red guys are next to each other. And adjacent, it's also next to, and so that one's a good. Alright, and the very bottom, so BC is an angle bisector to ECG. Alright, I'm not even going to go up here because there's, well, actually you can see it on the screen, hopefully, yeah, you can see the bottom. Alright, sorry, I couldn't see because of my laptop. I don't even need to look because I know there's no congruent marks, there's nothing telling me that, so this is a no. Okay, so like I said, the other side, you have some marks, see what you see, remember what this means, all that good stuff, and you guys should be fine. Alright, let me zoom out, or try to anyway. Yeah, there we go. Alright. Practice is 1 through 23 odd, and I have sheets for you guys if you were absent. Just let me know. Let's look at the summary real quick and we can wrap this up. So, given the diagram to the right, so over here, circle the correct answer. It can or cannot be assumed that GHM, so let's just go green, GHM and GJHK, so green and green, are congruent. Well, again, so there's nothing marked, so it cannot be assumed. So we're going to do, okay, just going to highlight it because, you know, why not? Alright, the second one, it can or cannot be assumed. The GHM, so I'm gonna, this is the same guy over here, I'm just going to go outside him a little. So GHM and M, so we're still in this, HK are adjacent. Well, if I color this in, so this guy, I know you guys will look at this line and say, no, what about this? Well, if we're talking about these three, we're talking about that angle. This guy is just in there. He doesn't count for what we're looking at. So these two angles, this small guy and this big guy, are adjacent, or next to each other. So that can be assumed. Okay. Number 2, determine if the following statement is true always, sometimes, or never. Explain your reasoning. Alright, so supplementary angles are adjacent and they form a linear pair. Always, sometimes, or never. Okay, so this one's a little complicated. So in order to be supplementary, they would have to be a linear pair. And I can't remember which part of this is what makes it sometimes and not never, but the answer is sometimes. I want to say they don't have to be adjacent, so they don't necessarily, which, yeah, supplementary angles actually, yeah, scratch all that, I'm overthinking again. Supplementary angles, they equal 180. They don't have to be adjacent, and they don't have to form a linear pair. They might, or they, so sometimes, but they don't have to. So, let me know if you have any questions. Until next time, have a good night.